Welcome to Head or Tail Education. Today we learn the limit in maths part 2. So to find left and right limits from the graph of function. So when graph of any function can draw easily, then we can read left limit or right limit of function easily on given point. Okay, so for example, the function fx modulus x divided by x when x is not equal to 0 and 0 when x equal to 0. So we have to find limit on point x equal to 0, the left and right limit in by given graph. Okay, so this is the graph. This is x-axis and y-axis, and middle point is 0, and the next point from left side is 0 is -1, and from right side is 1 on x-axis. Similar to y-axis, in bottom side 0 the point is -1 and upper side is 1. Okay, so in upper side we have the x is greater than 0, and in downside we have the x is less than 0. Okay, so solution. So first, on point x equal to 0 from given graph to read left limit. Okay, so first we read left limit on point x equal to 0. So how? So on points of towards left nearest to x equal to 0. Okay, the value of function is -1. So if we check here, the -1 is very nearest to 0. Okay, so this is the value of left limit -1. So if we go again left side, so -2, -3 like this. Okay, but -1 is very nearest to 0. So when leading from left side to 0, then the value of function leads -1. Okay, so limit x tends to 0 -1, 0 minus 0, fx equal to -1. So this is the left limit. Okay, by using the graph of function. Now check same like right limit. So on point x equal to 0 from given graph to read right limit. Okay, so we check the, so on point of towards right nearest to x equals to 0. Okay, so this is 1, this is next higher point is 2, 3 like this, but 1 is nearest to 0 from right side. Okay, so this is the value of 1. So when leading from right side to 0, then the value of function leads 1. So limit x tends to 0 plus 0, fx equals to 1. So this is the right side limit. Okay, join channel for more tutorials. Now next topic is existence of limit. So to find existence of limit, we have to note 2 points. So on any point x equal to a of any function fx, the limit will be exist if first on point x equal to a, both left and right limit is exist of function first, and second one is both limits are equal. Means the limit of x tends to a minus function fx equals to limit of x tends to a plus fx. Example 9. If function fx equals to 1 divided by modulus x, then find the left and right limit on point x equal to 1. The solution is for left limit, so point x equal to 1, so function 1 minus 0 equals to limit s tends to 0 f function 1 minus h equals to limit s tends to 0, the replaced by x 1 divide modulus 1 minus bracket 1 minus h equals to limit s tends to 0 1 divide modulus h, so equals to 1 divide 0, so equals to infinity. So this is the left limit. Okay, now check right limit. The right limit of f1 plus 0 bracket. Okay, so limit s tends to 0, so f1 plus 0 equals to limit s tends to 0, so 1 divide modulus 1 minus bracket 1 plus h equals to limit s tends to 0, so 1 divide modulus h equals to 1 upon 0 equals to infinity. So again we find the right limit infinity. So here we have left and right limit both are infinity. But according to our condition, on point x equals to 1, the left and right limit are not exist because limit value is infinity. Okay. Now next one more example for this according to condition. So if function fx equals to x divide modulus x, then find the left and right limit on point x equal to 0. So solution for left limit, function 0 minus 0 equals to limit h tends to 0 function 0 minus h equals to limit s tends to 0, replace x by 0 minus h and divide modulus 0 minus h, limit s tends to 0, now minus h divide modulus h equals to minus h upon h, so value is minus 1 on left limit. Now right limit, function 0 plus 0 equals to limit s tends to 0 function 0 plus h equals to limit s tends to 0, so 0 plus h divide modulus 0 plus h equals to limit s tends to 0 equal to h divide modulus h equals to h divide h equals to 1. So again the right limit is this time we were 1. Okay, now we have both limit, one is minus 1 left limit and right limit is 1. So the according to our first condition, the on point x equal to a, both left and right limit are exist, so this is exist. Now both limits are equal, but the both limits are not equal. Okay, so on point x equal to 0, the left and right limit are exist but not equal. Next one more example for our according to our condition, existence of limit. Function fx equals to 4 plus modulus 3x minus 2, then find the limit left and right on point x equal to 2 by 3. Check the solution. So left limit, function 2 by 3 minus 0 equals to limit s tends to 0 function 2 by 3 minus h. Okay, so equals to limit s tends to 0, put the value x equals to 2 by 3 minus h when s tends to 0. So 4 plus modulus 3 is multiplied 2 by 3 minus h minus 2 modulus. Okay, now cut the 3 and limit s tends to 0, 4 plus modulus 2 minus 3h minus 2 equals to limit s tends to 0, 4 plus modulus minus 3h equals to limit h tends to 0 4 plus 3h. Now put the value h equal to 0. So we have the limit 4. The left limit value is 4. Next, calculate the right limit. So function 2 by 3 plus 0 equals to limit h tends to 0. So function 2 by 3 plus 0 h. Here h is equal to 0. So putting the value 4 plus modulus 3 is multiplied by 2 by 3 plus h bracket and minus 2 equals to limit h tends to 0 4 plus modulus 2 plus 3h minus 2 modulus equals to limit h tends to 0 4 plus modulus 3h equals to limit h tends to 0 4 plus 3h. Now put the value h equal to 0. So we got the value of limit right limit equal to 4. Okay. So according to our condition, so limit h tends to 2 by 3 minus h is equal to means fx equal to limit h 2 by 3 plus h equals to fx equal to limit h 2 by 3 fx equal to 4. So all limits are equal means so on point x equal to 2 by 3 the left and right limit are h's. So this is condition true for limit existence. Now very important concept related to this. Okay, so limit n tends to infinitive. So a of power n equals to means 0 if a is greater than 0 and less than 1, and infinitive when a is greater than 1. So for proof this, so suppose we have n of power like 1 2 3 4 5 so on infinitive. Okay, so if a is positive number, first a is positive number and a is greater than 0 and less than 1, then high power will be very small number. For example, if a equals to 1 upon 3 which is less than 1, so if we have power 1 by 3 of power 2, so result is 1 by 9, and if we divide we got the result 0.1111 so on like. Okay, now increase the power 1 upon 3 of power 5, the value is 1 upon 243. Again divide, so we receive 0.00411. Okay, next increase the power again, this time power we have 10, so 1 upon 3 of power 10, so value is 1 upon 59,049. Okay, so if we divide this value we find the result 0.000016935. So according to result we have seen if the a is greater than 0 and less than 1, then a of power infinitive will be 0. Okay, next if a is again positive number and a is greater than 1, then high power will be very big, you know already very well. So for example, if a is greater than 1, then suppose a equal to 5, so 5 square equal to 25. If we increase the power, 5 of 6 equal to power 15625. Again we increase the power 10, so we have the value 97,65,625. Okay, so if a is greater than 1, then a of infinitive will be infinitive. Okay, the tell summary. In this tutorial we learned to find left and right limit from the graph of function with example. Next we learned the existence of limit and their rule with example. And finally, we learned an important concept of power for positive numbers between 0 to 1 and greater from 1 with example. Hope tutorial will help to understand about the limit in maths. Thanks to watch Head or Tail Education.